So next, we're gonna do how to represent functions. Well, a function can be represented by a table, or a graph, or a formula. Now here's a table. A function is just something that tells you from x, which x corresponds to which y. So it can be, what's this? Some temperature function, okay? So the hours is your x, which hour is what temperature. And the temperature is whatever it is. And you can show the function in the graph, of course. And that's not a graph, that's just a table. So, or you can show it in some kind of graph, which means you draw the Cartesian plane. Again, algebra, very important. And then, and you plot some points, which we will not do. And then you draw your function. Now, there's a specific point whether something is a function or not. A function, one definition part of the function is that the x can only go to one y, one value, okay? You cannot have, I mean, that is, what is the temperature at 5 p.m.? Well, it's 57 degrees. It can't also be 92 degrees. It just doesn't make any sense, right? So a function cannot have two values. And anytime, so when you draw a graph on the Cartesian plane, sometimes you can draw anything, and you can draw something that is a function that has two values. In those graphs, they're not considered a function, okay? There's nothing wrong with them, they're a graph. Any graph is fine, but it just, they're not a function by the definition of functions. All right, now next, let's think about zeros and the y-intercepts of a function, which is on page 17. What is this? This is example 1.3. All right, so let's do 1.3. All right, example 1.3 says that we have a very simple function. We'll just sit back and relax on a slow ride here. Okay, now we have a very simple function, and then it says minus 4x plus 2. And then we're supposed to find is 0 and y-intercept. Okay. Now, so the 0 is, what is a 0? What is a 0? A 0 is, it just means the f of x equal to 0. So, which has to be minus 4x plus 2. Now in this particular function, the range can be anything. So it can be 0, and if it's 0, then what does x have to be? Now you do your algebra and beat it around until you come up with something like minus 2 minus 4 equal to x, which is 1/2. And let's check our answer. Yes, that's right. So so when x is minus 2, if x is 1/2, y will be equal to 0. And then we have to find the y-intercept. What's the y-intercept? Well, the y-intercept is when the graph crosses the y-axis, which means x has to be 0, which is easier to do, right? So you just figure out what the value of f of x is when x is 0. So you put this in 0, and you get 2. So that's a piece of cake. And yeah, and then you have to sketch some kind of graph. All right, let's sketch. Okay, now when f of 0 is at 2, 1, 2, okay, that's one dot, and f of 1/2 is 0. So here's 1/2, and here's 0. So you draw this thing. Well, is convenient that calculators and of course computers can do the drawing nowadays. It's a good idea to draw a couple of these things once in a while, just to center yourself, so to speak, so that you remember how this is done. And once you know how it's done, then you can see a graph, and your brain comes up with a vague picture of what it should more or less look like. And that's often helpful in studying calculus, in making it easier. Okay, just that you know the stuff. You're like an experienced detective, so to speak. Next, yeah. Then we need to find more zeros, which I'm gonna skip doing that because example 1.4. But if you're not familiar with it or can't remember how it's done, remember to try to do example 1.4 or other similar examples yourself. Just do it without looking at the answer first and see if you get it, and then you can check to see if you're right. Now, okay, next, let's find, okay, a word problem. I'm looking at example 1.5, all right? So 1.5 is a word problem about physics, finding the height of a free-falling object. Now, physics is a very intriguing subject, and besides math, physics is probably the most logical thing to study in college. It's not as good as math, but it's close, right? But this stuff is, all right, so let's look at this particular problem of example 1.5, where a ball is dropped from a height of 100 feet, okay? So you have a ball dropping at 100 feet, that's all. And what are you supposed to do with that? Well, it's represented by some equation that's called S of t equals to minus 16 t squared plus 100. All right, so what about it? The S is the distance. That's usually represented by S in physics. I don't remember why. T stands for time, so that makes a little more sense. So then this is some kind of a, you see the ball starts at 100 feet, okay? And as time goes on, the 100 gets eroded, all the way down to 0, plunge. And the distance from the ground, you see when t is 0, s is 100, right? Because like we said, it starts at 100 feet. So we are supposed to create some kind of a table, all right, to represent the graph. Okay, so we'll do some kind of table. So here's the table. When t is 0, that's obviously 100. S is 100. Okay. Now, and we'll find when t is 1. And then S will be 100 minus 16, which is 84. And then what else do we want? Okay, when t is 2, S equals to, that's 4 times 16 is 64. And so you have 36 left. And then, all right, so with that, let's draw our little graph. It's 100, okay, when t is 0, this is S and t, and that's 0. Then when t is 0, it started at 100, and at 1, 2, at 1, t is down to 84, which is not that far down. And then t at 2 is all the way down to 36, so it's quite a bit down, okay? And then at some point, when t is 2.5, this thing will get completely knocked out, right? So it's at 2.5, it goes all the way down. So, well, when t is 2.5, then S is 0. That, I haven't done the math. That's just 2.5. Well, we'll just assume that it is, because that is what the book says, right? So the purpose here is just to show you how to draw the graph, or remember how it's done. Now this graph isn't the path of the ball, by the way. The ball isn't going this way. This is only the graphic representation of how tall, how high the ball is as it's being dropped. It looks a little bit like you're throwing the ball, but the ball is actually going straight down. Well, it doesn't really say that, but that's the normal assumption. You just drop the thing and then see how fast it goes down. All right, and that's that. So next, we're going to talk about increasing or decreasing functions. An increasing function is, I'll just look at it like this. What's an increasing function? An increasing function is a function that increases. This is going up. It's called increasing. That is, as x increases, so does the function. A decreasing function is the function that decreases. As x goes up, as x increases, the value of the function takes a dive. However, of course, functions can go wave around. They can increase sometimes and decrease sometimes. So anyway, so next we need to look at the function of a function. All right. Now, what is a function of a function? Is written as f circle g. That's a function of a function, which the better way of writing it, more clearer, is f of g of x. That's the combining. That just means you take g and becomes the new x. As an example, let's look at f of x. This is on page 20. Now you have f of x equal to x squared, and then g of x equals to something else, 3x plus 1. Okay, this is just some quick made up example. Now, first we'll find out what the combined function is. Now, first let's figure out f of g of x. Now remember the whatever's in here is the new x, okay? F is a machine, and then, well, so is g, but you take the entire thing of g and replace x with it in this operation. So, which means you take g of x. What do you do with f of x? F of x, the instructions, you take x, right? And you square it. That's the instruction that's the machine process for f of x. It takes the input and it squares it. It doesn't care what the input is. So what is g of x? G of x is 3x plus 1. So you put the whole thing in here blindly, because there's no need to think about this. Your job is to shove that into the input, and then the machine will process it by squaring it. Okay, and that's about the answer. Is just squared. You can also multiply that out, but right now the book is not requiring us to do that. So the next example, let's flip it around. We want to do g of f of x. Okay, that's the same principle applies. You take f of x, whatever's in the input, and process it according to the instructions on g. So so it's kind of like you're being a blender, and the blender's job is to take whatever you put in the blender and blend it. And it doesn't matter if you put in the old shoe, okay? Its job is to blend it. So we stick the f of x, which is, well, first let's see what g does. What g does, described by this, is 3 times the input, okay, plus 1. Doesn't matter what you stick in there, it will multiply by 3, then add 1. And what is the input? In this case, it's f of x, which is x squared. So what g's job is 3x squared plus 1, and that's about it. All right, next, the mathematical rules of functions. In terms, the rules are straightforward. When you have f plus g of x, when you add functions, how do you do it? Well, you add them up. It's the same as subtraction, multiplication, and division. The division with one string attached is that the denominator cannot be 0. If it is 0, then it's not defined for that value, but it's defined for all other values, as long as the denominator isn't 0, the function that is. Okay, now let's now being that that's straightforward, we will not go too much into it and talk about something else. Yeah. All right. Now, to combine functions, as sometimes they will also ask you for the domain and range. Well, you just look at the resulting. Once functions are combined, they become a new function, and you look at it for the domain and range. Maybe. Well, in this particular case, both cases, the domain and range, being that these are just polynomials, right? Just x to the second power, no square root, no fraction, no nothing. So the domain and range are both all real numbers. And then if you have some kind of a square root, then there'll be more limitations to it. But we'll skip that and do something else. That should be good enough. Now, sometimes we might talk about whether a function is symmetrical, that is, whether a function is even or odd. Yeah, well, that is somewhat helpful, I guess. For example, if there's a function such that f of x, right now I'm on page 26. Okay. So when a function is such that the value and its negative value are the same, then that's called an even function. Or this is called even. Or if some example of it, the most obvious example is f of x equal to x squared. So then when you put, being that it's being squared, it doesn't matter, f of 2 is 4, f of negative 2 is also 4. So f of a negative x is going to be the same because the squaring will cancel out the negative. So anytime the stuff that gets canceled out is considered even. And then there's another situation where f of x is always equal to where f of minus x equals to minus f of x. And in that situation, this is if that were true, the function will be called odd. And yeah, the thing about it is that the graph is then symmetrical toward is about the origin, which all right, let's talk about that. So for example, the most famous example is f of x equals to x cubed, and its graph, if you try to do f of minus x, you realize that it's the same as minus f of x. However, the graph of x to the power 3 looks something like, let's see, well, whatever. The graph of x power 3 is something like this, right? And it's symmetrical about the origin just means that this point has a mirror image from its corresponding point down here. So as it goes up, there's a corresponding point that's same distance from the origin down here. That's basically what it means. Whereas this one was symmetrical about the x-axis. So yeah. And that's all we want to talk about that. Okay. Next is the absolute value function. Remember what an absolute value is. it is you take the negative sign off. Okay, and with that, we finish chapter 1.1, which is a long ways from the end of the book, but one step at a time. There is no hurry.